So this is one type of the dynamic programming problem, and we can solve this with the recursion. At the same time, we can solve this problem with the dynamic programming. So I'm just gonna explain this for a second to show you some context. So this is really the assembly line of the car, right? So we have so many robots here, right? And the car flows like this way. This is a so typical way of saying the industrial engineering is important, right? So let's abstract it and make things a little simpler. And we have this production starts here and production ends here. And we have these stations all lined up here and stations all lined up here, right? And then this circle means that it takes time cost. So from the starting point to move to the station 1 takes 2 units of time. It takes 4 units of time to move to the station 2 and at that station, of course, this is another time cost. We need to take 7, 8, let's say minutes, and 9 minutes, 5 minutes, 3 minutes, 6 minutes. If we just follow that assembly line, it doesn't take time. However, if we want to switch the assembly line, we have to spend some time, like 2 minutes or 3 minutes or 1 minute, 2 minutes, and so forth. When the production reaches here, then this production line ends and the product is done, car is made, and then we can sell it, right? So goal is comparing the fastest production route from the start to the end, right? It seems so much kind of complicated with the look, right? How to solve this? Why don't you pause for a second and come up with an idea, right? Think about for 10 minutes and let's look at this. How can you solve this problem with the recursion? How can you solve this problem with dynamic programming? Just give a second for you to think of anything and then come back, right? Alright, so you just spend some time to think about how to solve this problem. Then let's see how we can solve this. One thing is a recursion, right? So I'm not going to explain all these things for this because that recursion is just a typical recursion. One thing is that we have this scheduling method here, and when within this scheduling method we have this scheduling like this, means that this is somehow the recursion, right? Function within inside that function with the reduced parameter set. And then there should be an escape routine right here, right? This is the escape routine because we can still return here, right? So this is one way of solving this assembly line problem with the dynamic program, with recursion. And I just recommend you to go home, stop this video for a while and type in this thing, okay? And see how it works. Alright, so that's the how to solve this problem in recursion, and this is how to solve this problem in dynamic programming, right? So the basic structure is this. So you have to set up some memorization table, right? Memorization table here, and then we are going throughout this for loop, we are going to make things grow, right? We are going to make things grow to reach to a certain point, and that certain point is here, right? So, right, so it's so complicated. I'm not going to explain this code for the whole, so I'm just recommend for you to stop this video for a while and type in, and then I will explain how it works. Right? You finish typing it and see how it works. Okay. So then let's see how it works. So imagine that a certain product starts this production line here. And then to reach to the station 1, so this is the time cost. To reach to the station 1, it takes 279 minutes, and 12 minutes. Means that this is the fast way. This is the fastest way to get to the station 11, station 11, and station 21, right? And then let's think about where it came from. It came from, of course, the starting point. So this trace indicates where it comes from. Where it comes from, right? And this is time cost. And of course, it came from the start line, right? So to reach to the first station 11, it takes 279 minutes. To reach to the station 21, it takes 12 minutes. And the origin of this product is just the starting point, right? And then the next thing is that to reach to the station 1, 2, what's the best way to get here? What's the fastest way to get here, right? So it takes what? 279 minutes here to come up here. So that's the 9 minutes. That's the 12 minutes, right? To reach to the station 1, 2, there are two choices here. So thing is that it might come from directly like this, making 18 minutes, right? And or the other way is that this 12 minutes product here might come to the 14 and might come to the 23. Of course, 18 would be our best choice. So to reach to the fastest way to reach to the station 1, 2, traveling like this would be the best answer. Means that this product might come from S11 and this product might come from S, right? Or I have to write this here, and this is coming from the starting point. And the same similarly, we have 12 minutes, the best way to get to the station 21. And what's the best way to get to the station 22? The answer is that if we just take the same thing from the S21 from the same assembly line, it will take 17 minutes, right? On the other hand, if we are going to take the product from the station 11, 9 minutes, 11 minutes, and 16 minutes, means that even though we are spending 2 minutes in the middle taking the product from the station 11 and making station 22 would be the best way to reach to the second procedure of this product. Assembly line means that we have to put 16 here, not the 17, because that 16 is the smaller value, and this is a better way to get to the station 22 rather than coming from the station 21, right? So the origin of this product would be station 11, right? Here is S, right? So we are going to say just the 1, and we are going to say just 1, right? The first this is the assembly line indication. So this is coming from the assembly line 1, right? This is coming from the assembly line 1, right? So we put 1 here in terms of where it came from, and we write down 16 and 18 to up to this point, right? So now you get the idea, and this value is the optimal, the fastest way to get to a certain station. If we compute till the station S26, station S16, then we might be able to find out which is the better way to start the line and what's the optimal trace, what's the optimal production trace of this product. So next step is calculating the fastest way to reach to this station 1, 3 and 2, 3. So up to this point, we have 2, 7, 9 and we have 12, right? And then the best way to get to here is that 9, 9 is the 18 and the 12, 14 and 23 means that 18 would be better, right? And then 9 to 11 and 16 and or 17, so 16 wins, right? So up to this point, this is the best way to get here, right? And then how about the next step? So if we consider station 1, 3, if we just take the product from this station 1, 2, it will take 21. How about here? If we take for the station 1, 3, if we take the product from the station 2, 2, it takes 16, 17, and 20. Means that this is the way to choose, right? So the activation would be taking the production line, taking the product from the production line 2. This is the way, right? Like this. This is the activated production line, rather than this way, because that is going to be 1 minute slower. And how about there? 16 and 6 means that 22 minutes if we take the product from the same production line, assembly line. If we take the opposite take it from the other line, it will take 18 and 21 and 27. Means that 22 is the better way to do this, and this is the way. Means that this is coming from the second line. This is coming from the second line of this source production source is. Means that 2, 2. So we write down 2, 2, and we write down 20, and then 22, right? And then let's compute this to the end. Then we have this result. Up to this point, I guided it for you. How about doing this for the rest of sequence for 4, 5, 6. And then you will find out this way. You will find out this table. These are the two memoization tables, right, to solve this problem. And then what you can do is that, all right, so how to do this? So how we are going to do this is that we are going to use this for the retrace purpose, right? For the retrace purpose. So up to the station 1, 6, station 2, 6, we have 35, and we have 37. Means that at the end of the day, we have 39, because we have to count 2, and we have 3 and 38. 38 minutes and 39 minutes. Means that we have to take it from the station 1, 6, right? 1, 6 would be a better way to do this. And where the station 1, 6 came from, the best way to get to this station 1, 6 is coming from the second production line, right? From the second production line, like this. And to come to this second production line of this station 5 is coming from the station 2, 4, right? The same production line. So it came from here. And to get to the station 2, 4, the best way is coming from the first production line, station 1, 3. Station 1, 3, right? And then to come to the station 1, 3, the best way to get here is coming from the second production line, station 2, right? This. And then coming to get to the station 2, 2, the best way is coming from the station 1, 1, right? This, right? So here. And of course, it is coming from the start line. So this is the best way to get through the product throughout this production line. Okay? So this is the one way of solving this complex, not really complex, but a production line problem with the dynamic programming and memoization. Remember that we grow the solution set here. We started from the to the problem of getting to the station 1-1 and station 2-1. And we made things grow. We make the solution grow by filling out, by writing down the memoization table elements, right? And when we were done with creating this memoization table, then we were able to retrace it, and then we find out how things work. The best production line of this within these assembly lines, okay? So much to suck up, right? So much to absorb, too much to run. So I would recommend that why don't you go home? Why don't you stop this video for a while? And this is the best way to understand this thing, right? You have to understand how it works. Then the best way is programming it, and the best way to programming it is the typing down by looking at this screenshot, okay? And you will find out how this works, okay?